Imagine paying $40,000 for an electric car, and 2 or 3 years later, discovering you have to shell out another $20,000 just to replace the battery. And worse, that battery could explode at any moment. This is the silent dilemma that thousands of drivers face today, and one that few discuss openly. The fear of an unexpected fire or a financial loss in the future remains one of the main barriers for those considering abandoning their combustion-powered car. And worse, this time, bomb lurks under the hood of most electric cars sold today, powered by a chemical that, until recently, seemed revolutionary: lithium. But what seemed to be the soul of electric cars is now showing its dark side. Lithium, extracted from unstable regions and processed with high environmental impact, is reaching its limits, both in durability and safety. Wear and tear is inevitable. Charging cycles are short, and the risk of overheating has become a real problem. Elon Musk, realizing this structural flaw, decided to do what many considered impossible: change the very heart of electric vehicles. And not only that, he wants to put an end to the lithium era once and for all, starting with Tesla's most affordable model to date. The 2026 Tesla Model 2 emerges as a direct response to this predicted collapse. It's not just a cheaper car, but a project that revolves around a new technological promise: the aluminum-ion battery. A change that may seem simple at first glance, but carries immense implications. This new battery not only solves the safety risks that plague lithium cells, but also promises a giant leap in durability and in consumer budgets. And we're not talking about distant promises here. The tests and data are already on the table. By replacing lithium with aluminum, Tesla is changing the rules of the game. The Model 2 doesn't just introduce a new type of battery, it ushers in a new vision of what a safe, durable, and, above all, affordable electric car is. The proposal is simple and straightforward: offer a battery that lasts more than 20 years without needing replacement and without the constant risk of fires. A proposal that, if it works as designed, could end dependence on lithium, one of China's greatest assets in the global energy landscape. And this geopolitical aspect matters more than many people realize, because today, whoever dominates lithium dominates the future of electric mobility. And in this context, China is several steps ahead. By cutting lithium out of the equation and focusing on aluminum, Elon Musk isn't just seeking a technical solution. He's trying to shift the industry's power axis. Tesla, with the Model 2, is aiming for something much bigger than a cheap car. It's trying to redefine what energy independence means in an increasingly polarized world. It's no coincidence that the announcement of the new battery came amid heightened tension between Washington and Beijing. This move reeks of industrial strategy, not just technological innovation. While the world watches the Model 2's price, the real impact may lie within what powers it: a battery that doesn't rely on Chinese mining or vulnerable export routes. If Elon Musk can prove that aluminum works at scale, he could be ushering in a quiet energy revolution. But it's not just the political landscape that's changing. What's at stake is consumer confidence. After all, how many people have held back from buying an electric car because they feared what might happen 5 years from now? The Model 2, by offering a safer and more durable solution, could put an end to that anxiety. What's more, it could transform the profile of the average Tesla buyer, previously restricted to those with higher purchasing power. The car will no longer be a risky bet and will finally become a viable option for everyday use. And that's where things get interesting. Because if a technology solves 3 problems at once: safety, cost, and durability, it not only attracts buyers, but forces the entire market to follow suit. The Tesla Model 2 isn't just another model in the company's lineup. It's a turning point, a watershed moment that could bury the lithium-ion era once and for all and usher in a new chapter in the history of electric vehicles. A chapter where battery fear gives way to confidence, and where the future, for the first time, seems secure. Aluminum may seem like a simple material. After all, it's in everything from soda cans to windows. But inside a battery, it transforms into something far more valuable. And this is where Tesla plays its boldest card, transforming this abundant and cheap metal into the new pillar of clean energy. While lithium requires aggressive mining and a complex logistics chain, aluminum is literally everywhere. Just to give you an idea, it's the third most abundant element in the Earth's crust, more than 1,000 times more common than lithium. And this abundance isn't just a curious fact, it completely changes the economic equation of electric mobility. Unlike lithium, which relies on mining in politically unstable and ecologically sensitive regions, aluminum can be extracted in locations with greater environmental control and social responsibility. This reduces its ecological impact, lowers transportation costs, and, most importantly, eliminates dependence on countries like China and the Congo. Furthermore, aluminum is 100% recyclable and maintains its quality after reuse, facilitating the creation of a much more sustainable production cycle that is less vulnerable to global disruptions. But it's not just its origins that make it stand out. What truly makes aluminum the new gold of clean energy lies in how it behaves inside the battery. One of the major flaws in lithium batteries is the growth of dendrites, small, sharp structures that appear inside the cell and can cause short circuits, fires, and even explosions. Aluminum, on the other hand, doesn't suffer from this kind of internal instability. The internal structure of the aluminum-ion battery simply doesn't allow for this kind of catastrophic failure. This means that even under extreme conditions, be it excessive heat, physical impact, or rapid charging, the battery remains stable. In laboratory tests, these batteries withstood heat without combusting, a feat that gives them a huge safety advantage over any lithium-ion cell on the market. This level of resilience is important not only for the average consumer, but also for insurance companies, fleet companies, and governments, which are still hesitant to adopt electric vehicles on a large scale due to the risks associated with traditional batteries. And if safety is already impressive, durability is even more surprising. While a lithium battery begins to lose performance after 1,500 charge cycles, aluminum-ion cells have demonstrated resistance to over 10,000 cycles with less than 10% capacity loss. In other words, we're talking about batteries that can last up to 30 years of continuous use. This isn't just a technological advantage, it's an economic game-changer. Instead of having to replace the battery every few years, a Tesla Model 2 owner can use the same cell for the entire life of the vehicle, and perhaps even longer. Longevity also drastically reduces electronic waste, a problem that's growing alongside the expansion of electric vehicles. After all, if every car needs a new battery every 5 or 6 years, the planet will have to deal with millions of tons of waste in a short time. The use of aluminum changes this. It allows for cleaner production, more efficient recycling, and a durability that drastically reduces the need for replacement. The environmental impact of a single car, therefore, is cut in half or even more. Another crucial factor is operating temperature. Lithium batteries require sophisticated cooling systems to prevent overheating, which increases the design cost and the car's weight. Aluminum, on the other hand, operates cooler by nature. This means not only is the risk of combustion reduced, but the vehicle's design can also be lighter and cheaper, freeing up space for further innovations and reducing overall energy consumption. A chain of benefits that feeds off each other. And it's precisely this chain that puts the automotive market on alert. Because, by solving several problems at once, Tesla's aluminum-ion battery not only positions itself as a viable alternative to lithium, it threatens to make it obsolete. And when a cheaper, safer, more durable and more sustainable technology appears on the market, you don't have long before it becomes the new standard. The lithium era may be about to end, and no one wants to be the last to notice. When talking about smart batteries, many people think only of the ability to monitor charge or alert when it's time to recharge. But what Tesla is implementing in the Model 2 goes far beyond that. We're talking about a neural management system that acts as a true digital brain, capable of learning, adapting, and protecting the battery in real time. This technology not only monitors basic parameters like temperature and voltage, but also analyzes usage patterns, weather, charging habits, and even the driver's driving style. It's as if the car studies its owner and knows exactly how to preserve its own energy health. This intelligent management allows the battery to self-adjust according to current conditions. If the driver tends to recharge during hotter times of the day, for example, the system can change the internal configuration to reduce thermal stress. If driving is more aggressive, the ion flow is redirected to less stressed areas of the cell, preserving overall integrity. All of this happens without the driver having to press a button. The battery's artificial intelligence simply understands the environment and responds to it in real time. And there's more. This autonomous management eliminates the need for complex cooling and safety systems. While lithium batteries rely on thermal buffers, liquid cooling, and external sensors, the Model 2's aluminum-ion battery uses its own intelligence to maintain stability. This reduces weight, simplifies vehicle construction, and reduces the risk of mechanical failure, while also opening up room for improvements in design, aerodynamics, and even energy efficiency. This intelligence also has a direct impact on charging speed. Thanks to aluminum's atomic structure, each ion carries 3 positive charges, compared to just 1 for lithium. This means more energy can be stored and transferred per cycle, resulting in charging up to 3 times faster. For drivers, this means less time at the plug and more time on the road. And because the intelligent system learns the best charging times and patterns, it helps maintain optimal performance even after thousands of cycles. This incredible performance doesn't come at the cost of durability. Quite the opposite. The battery's AI constantly works to balance performance with cell conservation. If necessary, it automatically reduces the discharge rate to prevent overheating, or delays full recharge in specific situations to extend battery life. It's a mutually protective relationship. The driver takes care of the car, and the car takes care of the battery, without anyone noticing. Another interesting point is that this system paves the way for predictive diagnostics. Over time, the software will be able to alert the owner to wear and tear before it becomes a problem. Instead of dealing with unexpected failures, the user will be notified in advance based on real-world usage data. It's as if the car is saying, "Hey, maybe it's a good idea to change your charging pattern this week." This ability to predict the future, based on real-world patterns, takes the Model 2 to a whole new level of technology. And it's not just for individual use that this stands out. On a large scale, this intelligence can be applied to fleets, optimizing each vehicle independently and reducing maintenance costs for companies. Insurance companies can also benefit, offering more personalized plans as they will have access to more accurate data on battery usage and associated risks. The result is a smarter, more connected, and more efficient automotive ecosystem. With this approach, Tesla isn't just selling a car, it's offering a living platform that evolves alongside the driver. The Model 2 learns, adapts, and improves over time. And this transforms the driving experience into something completely new, a dynamic relationship between human, machine, and energy. The idea that a car can pay its own bills still sounds like science fiction to many. But Tesla is turning this fantasy into something increasingly concrete. The Model 2 wasn't designed just to save energy. It was built to generate revenue. This starts with the aluminum-ion battery's ability to withstand high discharge rates without compromising its durability. In other words, it can transfer energy outside the vehicle without suffering from it. And that's precisely where the financial potential comes in. Charging other electric vehicles, powering homes, or even selling electricity on the street. Imagine being parked and earning money while your car shares some of its charge with another driver. With Tesla's peer-to-peer energy system, this will be possible. The vehicle will be able to identify, through sensors and blockchain connection, other nearby cars that need energy, automatically negotiate the price, and securely transfer the battery. Based on average US charging rates, a simple 10 kilowatt recharge can yield $5 to $7. Multiply that by 3 small transactions per day, and we're talking up to $900 per month without leaving your seat. This microtransaction model transforms the battery from an expensive liability into a profitable asset. And the big advantage is that, with over 10,000 lifespans, the aluminum-ion battery doesn't suffer significant wear and tear even when used daily as a source of income. Unlike lithium batteries, which wear out quickly with this type of operation, Tesla's technology ensures that profit doesn't come at the expense of longevity. What was once a concern, "Will I ruin my battery?" becomes a new type of personal investment. This ability to generate direct revenue expands the car's role in the driver's life. It ceases to be merely a means of transportation and becomes a generator of opportunities. In neighborhoods where energy access is limited, or at events where electrical infrastructure is precarious, the Model 2 can become a highly valuable portable power source. And all of this is controlled by artificial intelligence, without the user's effort or technical knowledge. Beyond direct profit, this battery offers a strategic advantage: mobile energy security. In emergency situations, the car can act as a backup power source for hospitals, schools, or homes. In places affected by natural disasters or power grid failures, the Model 2 doesn't just help, it saves the day. This also creates space for partnerships with governments, city halls, and logistics companies, which can use Model 2 fleets as self-sufficient mobile power stations. Another notable factor is the battery's stability even under pressure. Unlike lithium cells, which can become volatile with intense use, aluminum maintains its structure intact even under thermal stress or physical impact. This allows for safe public energy sharing, without fear of accidents, short circuits, or explosions. Tesla's proposed financial model also includes integration with a blockchain-based credit system. This technology will allow users to record each energy transaction transparently. With automated digital contracts, energy will no longer be simply a consumed resource, but will be traded as a digital asset, with the potential to boost the local economy and create new business models. In this scenario, the car becomes a passive income platform, and the driver, a small energy entrepreneur. While the world is still debating incentives and subsidies for the electrification of transportation, Tesla is already testing something much more ambitious: a car that pays for itself. Not with vague promises or theoretical advantages, but with real cash flow, directly from the battery to the owner's pocket. If the idea of making money with your car already seems tempting, imagine cutting essential household costs using that same vehicle. That's exactly what the Model 2 aims to do. With its 90 kilowatt battery, it has enough capacity to power an entire home for up to 4 days in an emergency or during peak hours. And most impressively, without the need to install any additional equipment like a power wall. Just plug it in and go. Your home keeps running, even if the grid goes down. This kind of energy autonomy is a game changer for families seeking security,